A boy places a firecracker of negligible mass in an empty can of 40-gram mass. He plugs the end with a wooden block of mass 200 gram. After igniting the firecracker, he throws the can straight up. It explodes at the top of its path. If the block shoots out with a speed of 3 meter per second, how fast will the can be going? So it means we are given the masses of the can and the wooden block, and we are given the velocity or speed of the wooden block, and we need to find the velocity of the can. So once again, let's see a simple animation to understand what is going on. Then we will come back to this question to solve it. So here is a boy with a firecracker. So he will fire the firecracker, put it in the can, and then he will plug this wooden block to close the opening of the can. Then he will throw it up, and when it reaches at the maximum height, it will explode. So let's see the animation. So he is going to fire the firecracker, then he puts it inside the can, then he plugs the can with the wooden block so that the opening is closed. In the next step, he throws it straight up, and when it reaches at the top mean it will still for a moment, and then it explodes like this. So let's try to understand the problem. So when it reaches at the maximum height or at the top of its path, it will be still, mean it will not be moving. It will be at the same point for a moment before it could fall down, but before that it explodes. So when it reaches the maximum height, their velocities, mean velocity of the wooden block and velocity of the can, they are equal to 0 because it reaches at the maximum height. And when it reaches at the maximum height, it explodes. So of course, because when the boy places the firecracker inside the can, it was burning, and because of the burning, the gas was accumulated in the can. And when it reaches at the maximum height, the pressure of the gases was too much, so that it explodes. And because of the explosion, the wooden block will move this way and the can will move this way according to the orientation we have chosen. So before the explosion, their velocities were 0, and after the explosion they gave us that the wooden block moves with a velocity or a speed of 3 meter per second, and we need to find the velocity of the can. So in my experience, whenever you are given such problems in which a system is composed of 2 or more components and they are combined somehow, like in this case the wooden block was plugged into the can, opening was closed, and firework was burning inside, and then something happens and those components, they detach from each other. So whenever you have a problem like this, in my experience, you can always use the law of conservation of momentum to deal with masses and velocities. So they will give you the masses, they will give you the velocities, and usually one velocity is missing. You can use the law of conservation of momentum to find out that missing piece of information. And at this stage, because they told us it reached the maximum height, so we just assume, it's easy to assume that the initial velocities were of course 0, and after the explosion we are given one velocity, and we can find the velocity of the can very easily. So always remember that whenever you are given a system which is composed of one or more components and they are together, and then some event occurs, is maybe the explosion or whatever, and they are detached from each other, and if they ask you to velocity of one or more components and masses are given, so masses and velocities, we know that the momentum is the product of mass and velocity, and if the problem is related to velocities or masses, you can always find the missing quantity because the other quantities will be given to you. So let's go back to the question and we can. Okay, so before we can solve the question, let's arrange the data and define the variables. So there are two components in this question. One is can and one is wooden block. So I will define as the mass of the can as m1, which is equal to 40 grams as given in the question. And let's do some extra work. I told you always present the units in SI standard units. So and the SI unit for the mass is kilograms. Let's convert this value into kilogram. So 40 divided by 1000, and it is equal to 0.04 kilograms. So this is mass of the can, and then let's say mass m2, which is mass of the wooden block. And let me find where is the mass of the wooden block is given. It's here, 200 grams. So 200 grams, and let's convert it to kilograms. And it's equal to 0.2 kilograms. Okay, so just remember, this is mass of the can, and this is mass of the wooden block. So now we will use the law of conservation of momentum. So let's define the velocities. So two types of velocities are used in this problem: the velocities before the explosion and velocities after the explosion. So let's define those velocities as well. So here I will define the velocities of the can and the wooden block before the explosion, and here the after, because this is very important to define the variables for relative velocities, otherwise you can make a mess out of it. So before the explosion, let's say the velocity of the can, which is v1, because we assign m1 as mass of the can, so let's use the same notation. So v1 is the velocity of the can before the explosion, and v2 is the velocity of the block. Of course, this is before the explosion. And similarly, v1 prime is the velocity of the can after explosion, and v2 prime is the velocity of the block after explosion. So now we have defined all the variables, and we can go to solve the question. So the law of conservation of momentum says that momentum of a system, or if a system is composed of components, then the sum of all the momenta of the individual components before the event equals momentum before the event equals momentum after the event. So this event can be anything. In our case, it is explosion of the can. So momentum before, it means this is momentum of the total system, or the sum of the momenta of all the individual components. So for example, in our system there are two components, one is can and other is the block. So we will write the momentum of can and block. So we know momentum is mass times velocity of that component, so let's write it m1 v1 plus m2 and v2. So this is the total momentum of the system, which is the sum of the momenta of individual components. So we have written the total momentum as a sum of the individual momenta, and this is equal to the momenta after the event or explosion in our case. So I will write it as m2, and no, it should be m1, because I am writing the momentum of the can first, to m1, v1 prime, because after the explosion mass remains the same, so I am using m1, but now the velocity has changed when the can explodes, so m1 v1 prime plus m2, the mass of the block, and v2 prime. So this is the law of conservation of momentum. Momentum before and after the event, it is equal for a system. Or if the system is composed of individual components, then we need to write the sum of all the individual momenta of the components. So we know that v1 and v2, this is the initial velocity according to my animation, or the velocity before the explosion, and we know that it was at the maximum height or at the top of its path. So we know when it reached at the maximum height, it was still for a moment. So these velocities are 0. It means the left side will become 0. So this whole side will become 0 equals m1 v1 prime plus m2 v2 prime, because I am interested in finding v1 prime, and if I show you that v1 prime is a velocity of the can after the explosion, because I want to find it, so I will just isolate it. So I will bring this term onto the left side. It will become negative m1 v1 prime equals m2 v2 prime. So I will write it as v1 prime equals negative m2 v2 prime divided by m1. So now we need to plug in the values, and you will find the velocity of the can after the explosion, because m1, m2, the relevant masses are already given. v2 prime, the velocity of the wooden block after the explosion, is also given. So let me show you in the question that it says if the block shoots out with a speed of 3 meters per second. So this is actually v2 prime, because we define v2 prime as the block velocity of the block after the explosion. So just remember this value, and I will plug in the values now. So m1 is 0.04 kg, so m1 is 0.04 kg. Of course there is a negative sign. And then let me see what is m2. m2 is mass of the block is 0.2 kilogram. And then v2 prime. So v2 prime, let me just find it from the question itself, because I didn't write it in my data sheet. It's 3 meters per second. And my calculator tells me that the value is negative 15 meter per second. This is v1 prime. So the block will move with a velocity of 15 meter per second, and negative sign just tells us that the direction of this velocity is opposite to the velocity of the wooden block. And we have seen in the animation that they actually move in opposite direction. They will always move in opposite directions, no matter whatever is the orientation of the block. So here is your. So before I end this lecture, let me tell you some extra information. You are not supposed to solve it in that way, and it is beyond the scope of your course. But if you appear for a competitive exam or some interview, they might ask you a question like this. So you're not supposed to solve the question, but at least you must have a good scheme to solve the question. So here is the piece of information I want to tell you. So we assume that he puts the firecracker, which was already ignited, in the can, and then he plugged the opening with the wooden block. He throws up, straight up. So in this question, or according to my animation, we assume that the orientation of the block when it goes straight up was horizontal. So can was like this, and we assume that the wooden block was on the left side, and then it explodes, and we assume that the can will go to the right and wooden block goes to the left according to our animation or imagination. So I will just present some questions to think about it. If I assume that when he throws the block straight up, it was not horizontal, in fact it was vertical, and the wooden block was at the top. So he plugged it this way, and when he throws straight up, the wooden block was at the top. So if we assume the orientation was like this, what changes will you make if everything else remains the same? So what changes you will need to make to solve this question? Just think about it. Of course the direction will change, because after the explosion now the block will fall down to the earth and block will go up, and of course it will reach a certain height, and then it will also fall down to the ground. But will you need to change something? I mean, in the calculation we have just done, will you need to change something? Just think about it. So I tell you that as long as the condition that it was at the maximum height or at the top of its path, it doesn't matter whatever was the orientation or whatever orientation you assume, it will not make any difference. So you can use the same calculations. The only difference is the change in the direction of the velocities, but that is not that much relevant in our case. So you can just see that the velocity is now for the block in that case will be up, and velocity of the can will be downward, and you will find the same thing, because you will find one velocity like velocity of the can as negative v1 prime or something like that. So they will remain opposite, but their directions will change. But this is only true as long as the condition that it was at the maximum height, mean it was actually still where we can assume that the initial velocities v1 and v2 were 0. You don't need to change anything, even if you assume that the block was diagonal when it was at the maximum height and then it explodes. So nothing will change. But if they ask you that block was at certain height, not at the maximum, it was actually at certain height, and they will give you this number, actually maybe 2 meters or something. So if they ask you that now what changes you have to make to solve this question, will the calculations be same? So this is a bit complex question, and you can just think about it. We don't need to do much analysis. That when it is at h, now you have to make some changes to the calculation.